So today we will learn 12 applications using the quadratic formula. And the one we're going to concentrate on today is the area formula. And that says, we'll just focus on rectangles. That says if you have a rectangle, and say this is the length and this is the width, an area equals length times width. And because you're taking length times width, that's two variables, it's going to end up being to the second power, which is now solving using quadratics. So an example, the park shown is 16 square meters in area. So the park is 16 square meters. Square meters, that means the area. You may also, science class is this, 16 square meters. If the length is 6 meters longer than the width, so if the length is 6 meters longer than the width, then what are the dimensions of this park? Well, let's let the width be W. And if the width is W, then the length is 6 meters longer. That would be W plus 6. Does that make sense? So we have the width, and the length, which is 6 meters longer than the width. That'd be W plus 6. Now, what are the dimensions of the small park? Well, we could put these two together, and we get W times W plus 6 equals 16. And all I did was I used the area formula that said width times length equals area, where my width is W and my length is W plus 6. So that's how I got my equation. From there, I distribute, I get W squared plus 6W equals 16. So that's a quadratic. That means there's two solutions. Best to put it in standard form. So move over the 16. And now what we're going to do is we're going to plug in to the quadratic formula, A, B, and C, and figure out what we get. A is 1, right? B is 6, and C is negative 16. Plug in the formula. That's negative b plus or minus square root b squared minus 4ac all over 2a. Or if you know how to factor, you can do it that way, or complete the square, or by graphing. Just know a system, okay? Or a method. So plugging in, negative b would be negative 6 plus or minus square root b is 6 minus 4a is 1 and c is negative 16 all over times a, which is 1. I showed you this last week to just punch this all in at once. so you don't have to worry about order of operations. So I get 4, right? 2 times 1 is 2, so I get 4 over 2. And then my other one, I'm doing minus, I get negative 16 over 2. Four over 2 is 2. Negative 16 over 2 is negative 8. Now, if you think about it, this is saying either x, which would be our w, right? I should have probably used w. Just so I get so used to using x. So w, does it make more sense for the width to be 2 or the width to be... Can't really have a negative width, can you? So you're going to go with this one and not this one. Yeah, sometimes there could be, yeah. I would list them both. So, what are the dimensions of the park? The dimensions of the park is 2 meters by, so if that's 2, then this would be 2 plus 6, right? 2 meters by 8 meters. That should work. I'm going to check our work. 2 times 8 is 16. So the dimensions of the park is 2 meters by 8 meters. It's not a very big park. Actually, the whole thing doesn't make any sense. 2 meters by 8 meters. That makes absolutely no sense. That's really, 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 really small. You guys know how big a meter stick is, right? One of those, I don't have one, but it's like this long. So that's how big this park is. It's like, oh, I'm 2 meters tall. So the park is my width or my height, I'm saying, and then that just doesn't make any sense. All right, next. The combined area of 2 squares is 20 square centimeters. The bigger square has sides twice as long as the little square. Find the dimensions of the 2 squares. So, reading the problem, we have 2 squares. We have a little square, I'll even call it little square, and a big square. All right, bigger square. So it's got to be a little bit bigger. And we know property of a square is length equals width. So the combined area of the 2 squares is 20 square centimeters. The bigger square has sides twice as long as the little square. Find the dimensions of the 2 squares. So I'm going to start and say, let's say this is x. If the width is x and it's a square, what's the length? It's also x, right? It's a square. And then the area of an x by x squared would be x times x squared. That's the area. I like to write that in the box, okay? And then the bigger square has sides twice as long as the little square. Well, twice as long, if this is x long, twice as long would be 2x. Does that make sense? And if that's 2x and it's a square, this is also 2x. So the area of this square would be 2x times 2x, 4x squared. So now we know the area of little square is x squared. The area of big square is 4x squared. And they tell us the combined area of the two squares is 20 square centimeters. So they tell us that x squared plus 4x squared equals 20 square centimeters. So my mathematical formula will be x squared plus 4x squared equals 20. Does that make sense so far? And then 1x squared plus 4x squared is 5x squared. And you could, there's two ways to solve this. You could write it as 5x squared minus 20. You could do this. And then you'd say A is 5, B is 0, C is negative 20. And you could just use the quadratic formula. But anytime there's only two terms, I solve using radicals. So divide both sides by 5. It's way easier this way. And then you get x squared equals 4. And then take the square root of both sides. And you get x is plus or minus 2. And had you used the quadratic formula, you would also get plus or negative. Now, negative 2 makes no sense. So I'm going to go with 2. Find the dimensions of the two squares. Okay. The little square is, and we're talking about centimeters, is 2 centimeters by 2 centimeters, and the bigger square is twice as long. Well, if this is 2, that'd be 2 times 2 would be 4 centimeters by 4 centimeters. Checking my work. 2 times 2 is 4. And 4 times 4 is 16. 4 plus 16 is 20. It does work. Any questions? I would highly encourage that when you do these that you draw pictures. Pictures help. Are you guys almost done copying this? Oh. You guys know how big a centimeter is, right? Really tiny. Bilbo Baggins wants to make his dining room bigger in case he has another unexpected dinner party with some dwarves. Okay. Currently, Mr. Baggins has a 600 square foot dining room that is 20 foot wide. He wants to make his new dining room 875 square feet by adding the same amount to the length as the width to accommodate dwarven and wizard party guests. What are the new dimensions of the dining room table? So we have a dining room table. Again, I like to draw pictures. And this is his current table. And he's going to do stuff to it. to make a new table, and I think he said it's going to be bigger, so we could have more people over. Pictures do all kinds of wonderful things for us. Okay. So I read the question, I drew a picture. Now I'm going to fill in a picture. So he wants to make his dining room bigger. Okay, it's not a table, it's just a dining room. And I guess we're going to assume that his dining room is rectangular. That's not always the case. Currently, he has a 600 square foot dining room table. So I'm going to put that here, 600 square foot. I like to put the area inside the box. That is 20 by 30 wide. So it's 20 feet long by 30 feet wide. Okay, I got that from here. And to confirm, 30 times 20 is 600. Okay. He wants to make his new dining room 875 square feet. So he wants it to be 875 square feet. And I got that from there. And he wants to do this by adding the amount to the length as the width. So we're going to add the same amount to the length, same amount to the width. Your choice what variable. I'm just going to choose x. In other words, he's going to take x and add it onto that 30, but he wants it to be the same for the length, so this is going to be 20 plus x. Does that make sense? He's adding the same amount to the length, well, 20 plus x, as the width, 30 plus x. What are the new dimensions? So now I have an area formula that says 30 plus x times 20 plus x is 875. And for whatever reason, it bothers me having the number before the x. I'm going to rewrite this as x plus 30 times x plus 20, which is a legal move in math. It's the commutative property. Okay. Now, it's easier for me. I'm going to take this binomial times this binomial. We reviewed that. X times x is x squared. X, 30 times x is 30x, and 30 times 20 is 600. Combine like terms. 20 plus 30 is 50. Minus 875 from both sides. And 600 minus 875 is negative 275. And then from here is review. We're going to use the quadratic formula. A is 1, B is 50, C is negative 275. It's going to spit out two answers. We're going to take the positive one, and if there's more than one positive one, like you asked, it depends what the question's asking. Like you want to minimize or maximize, and I don't think we're going to get into that. But then that's going to spit out the x, which then we can just take the x plus 20 and the x plus 30, and that will be my new dimensions. So using this, A is 1, B is 50, C is negative 275. I don't have room for it, so I'll write it over here. So for b, negative 50, minus square root b squared, b is 50, minus 4, a is 1, c is negative 275, all over 2a, and a is 1. And this is x equals. Again, I would just type that in your calculator all at once. Negative 50 plus square root 50 squared, 50 squared minus 4 times 1 times negative 275. You get 10. And then 2 times 1 is 2. And then the other one will be at the minus. That's negative 110 divided by 2. This is 5. 10 over 2 is 5. This is negative 55. So you're going to go with this one. So you're going to add 5 feet to both sides. So what are the new dimensions? The new dimensions will, it was 30, but now we're going to add 5 to it. So it's going to be 35 feet by, it was 20, but we're going to add 5 feet to that, by 35 feet by 25 feet. And 35 times 25 is 875. Does that make sense? If this were an ACT question, I would not do all this work. I would plug in the answer choices until I found one that when you multiply them, you got this number. Does that make sense? Like if A was 1, then I would take 31 times 21. And let's say B was 2, then I would take 32 times 22. Lonnie's pool is 150 foot long and 75 foot wide. He wants to put a uniform. Uniform means same. Okay, that means same.